Hi. This video has two parts. First, we are going to talk about using quadratic formula. I want to go over all tricky places where people usually make mistakes. And the second part, it will be about not using the quadratic formula whenever possible. Okay, so let's use this one to go over all these tricky moments. This is the quadratic formula, as you know, where a, b, c are coefficients in a quadratic equation. This is one of the formulas that you actually have to memorize. It's not easy to just make sense out of it. Derivation process is pretty complicated, so you need to remember it. Okay, so let's start using it. First step, before we start plugging in ABC, we really need to write it in this form, standard form, with the equal 0 to 0 on the right. So we are going to move 6x to the left, it becomes minus 6, and 7 to the left, it becomes minus 7. Now we have our A, B, and C. Don't forget that they carry the sign. So x equals minus b, which will become 6, because b itself is negative, plus or minus square root of. I need to square b. My b is negative 6, but I'm not going to write negative 6 squared. First of all, the way I wrote it here is just wrong, because minus 6 squared is actually minus square of 6, which is minus 36. It's not what I want. If I really want to square negative 6, I would have to write this. But I'm not going to do it, because negative number squared is still positive. So I really not going to write minus 6 over here. I just write 6 squared. Or better yet, I'll just write 36, because I can easily do it in my head. If not, yes, you have to write it down, but don't do this. This is bad. Because if you type it in your calculator, the calculator will tell you minus 36, and it will be wrong. All right, we continue. So we have we have b squared minus 4ac. All right, 4 times a, which is 2, times c. This is one common issue. C in my example is negative, so I really must write it down. Okay, continue. And we divide this by 2a, so it's 2 times 2. Now we are going to simplify it. So 6 plus minus square root of, we already have 36. Now 4 times 6 is 8, times 7 is 56. But important thing is that we multiply negative by negative. So actually it becomes plus 56. So this is the source of many mistakes. Whenever c coefficient is negative in a quadratic equation, we will always end up with this situation. Minus comes from the formula itself. The second minus comes from the equation. So we always will get this plus in our equation. Okay, so divide by 4. Continue. 6 plus minus square root 36 plus 58, it's 80 and 12, 92, right? Right. Okay, unfortunately, I'm not done. I strongly suspect that my 92 can be simplified. The answer for quadratic equation, the irrational numbers that we get, always must be written in the simplest radical form. I suspect that 92 must have a factor of 4, because both 36 and 56 have factor of 4. I can see it from here. So if I don't, I would have to find prime factors of 92, but I'll start with a 4. Maybe there is more. So 4 goes into 92. How many times? 2, 23 times. Okay, 23 is a prime number. So I can break it down now as square root of 4 times square root of 23, and square root of 4 is 2 times square root of 23. That's what I'm going to replace this with. 2 times square root of 23 over 4. And the final step, I'm analyzing, comparing the numerator and denominator. 6, 2 in the numerator and 4 in the denominator. I can reduce this fraction by 2, because 2 goes into each part of it. 6 divided by 2 is 3. This 2 divided by 2 is gone, and 4 divided by 2 is 2. This is the answer. There are two answers here, one with a plus, one with a minus. If you need to evaluate them, round to nearest something, depending on the situation, you would need to use a calculator. I want to go back for a moment at this place. So one common mistake that people are making is this. Let's look at it. You can see, you can reduce by 2, like right here. 6 divided by 2 is 3. 92 divided by 2 is 46. And this is 2. Bad. Really bad. Why is that? Square root of 92, as we saw, is not 2, is not 2 times square root of 46. This is wrong. 2 that is sitting inside of 92 is not really a 2. And the 2 that we have here outside, this one, 2 radical 23. Inside of the square root, it actually is a 4, because, as you just saw, square root of 4 gives us 2 outside. So when we cancel by 2 in this fraction, we divide by 2, we divide by 2, we divide by 2, but inside the radical, it kind of, we divide by 4. In other words, what you really need to remember, that in a situation like this, you must be careful. You may want to take a side note, simplify your radical separately, and then you divide by 2 every term of this fraction. Another mistake that I have seen is this. But let's look at another example. Suppose you simplified already your answer, and you got something like this, maybe something like that. So what people do, they divide by 2, just 6 and 4. So they get 3 plus minus radical 13 divided by 2. So 6 got divided and 4 got divided, but not radical 13. So this ruins the main property of a fraction. You cannot reduce, let's say, imagine a simple number that you know, 6 plus 5 over 4. It's not the same as 3 plus 5 over 4. You can check yourself if you don't believe me. So these are a couple important moments, a couple potential mistakes as you are working with the quadratic formula. And now we will talk about equations, quadratic equations, where we really don't want to use quadratic formula. I know that some people do it, but let me show you why you shouldn't. So let's say you want to use quadratic formula for this first binomial. Let's just use it. Let's go. So x equals minus b. Ooh, is it 11? Yeah, that's what many people do. But the truth is, 11 here, negative 11, is a c, and b is missing. So b is really 0. So it will be 0 plus minus b squared. What's my b again? Oh, it's 0. So 0 squared minus 4 times a times c, which is negative 11. Divide by 2 times a, which is 9. Okay. So 0 plus minus, so I don't need 0 really. Plus minus square root, 0 squared is 0, minus negative times negative, again positive. So it's 4 times 9. Ooh, I'm actually not going to multiply them out. You will see in a moment why. But to make things worse, to demonstrate my point, I should have, but I'm just lazy to do that. The reason I didn't want to multiply, because I actually want to simplify it now. And in this form, it's already broken into my perfect square factors. So I can see square root of 4, which is 2, square root of 3, square root of 9, which is 3, and 11 is the only thing that remains inside the radical, divided by 8. And now I need to simplify it. So it's plus minus. This is 6, so I can cancel, reduce by 6, and that becomes 3. Square root of 11 over 3. That's my answer. Whew. So let's go over a couple potential mistakes that you could have made here. So first, really easy to mix up this coefficient. So often I've seen how people are using 11 for b and then 11 for b again. That's bad. Second, it's somewhat confusing when you do 0 minus 0 minus. Yeah, I guess that's about it. Now let's solve this without quadratic formula. So I'll write this down again. 9x squared minus 11 equals 0. The simplest solution would be to add 11 to both sides, and then you have 9x squared equals 11, and then you divide both sides by 9. And then you need to get x by itself, so you need to take a square root. Remember, when you unsquare a positive number, there is always positive and negative solution. So it's a square root of 11 over square root of 9, which is 3. That's your answer. So much faster than this, and so much less, a few opportunities for mistakes. You just need to remember about this plus minus. Okay, let's solve this one now. Using the quadratic formula first. X equals, so it's minus b, so it will be minus 5 plus minus square root of b squared, which is 25. You see how I didn't write it down? It's easy to do in my head. Minus 4 times a times c. Where's my c? Oh well, no c, so it's a 0. Divide by 3 times 2. We'll simplify. Minus 5 plus minus square root of 25 minus nothing, it's a 0. Divide by 6. And then minus 5 plus minus square root of 25 is 5 over 6. And that gives us two options. Minus 5 plus 5 is a 0 over 6, which is still 0. And minus 5 minus 5 is negative 10 over 6, which we can reduce. And it's negative 5 over 3. So we have two solutions. Well, it's not too bad. But let's look at another option. So let's write this down again. Look carefully. How could you solve this differently? Yeah, you can factor out x, and that becomes 3x plus 5, and you already probably see the answer. So this gives us x equals 0. This gives us 3x plus 5 equals 0, or x equals negative 5/3. So much faster. In conclusion, so let's look at these two equations. Both of these are quadratic binomials, not trinomials. Quadratic formula is pretty complicated, and it's used in a case when you have all three terms. But in this case, they are special, they're easy, you don't need quadratic formula. In this case, where b is missing, you have x squared in only one place, and then the number. So it's easy to isolate x squared and then just take a square root. In this case, term c is missing, constant, so both terms contain x, and therefore x can be factored out easily. And it's always the case when you have equation with a missing c. So always these equations have one of the solutions 0, which also makes sense because the y-intercept here is 0. You see? All right, that's it. Happy solving.